Hey guys, how's it going? So here in this video we have an assortment of angle problems. So we've got some bearings, we've got angles between parallel lines, we've got some proofs, we've got angles and polygons, including interior angles and exterior angles. So if you're watching this before the Paper 3 exam in 2018, this is relevant to everyone, AQA, Edexcel, Foundation and higher. I've taken these from an assortment of different papers. If you're watching this at some point in the future, awesome, hello. So, first up we have a couple bearings questions. So, here we've got this diagram with points A, B and C. We are asked, what is the bearing of C from A? So be very careful about the language that they use. The bearing of C from A is asking then, if we're at point A, what bearing do we have to walk on to get to point C? Now remember, north is always 0 degrees and we always measure bearings clockwise. So around like that. Now this one's quite nice. We've already got two angles there. So we just need to add 130 and 80 together and we will get 210 degrees. While we're here, I'm going to take you through how we could work out the bearing of A from C. So, A from C. So this time we are at C and we want to know, how do we get to A? So again, north is always 0 degrees and we measure bearings clockwise. So we need this angle here. Now to work out that angle, we need to work out this angle. Those two angles are co-interior, so they add together to give us 180. So to work out this angle up here at point A, we need to remember angles around a point add up to 360. So we've already done 130 add 80, which gives us 210. So this angle will be 360 minus 210, which is 150. So this angle here is 150. Now as I said, that angle and the bearing that we want are co-interior angles. Co-interior angles sum together to give us 180. So the bearing of A from C is 180 minus 150, which would be 30. But remember, bearings are always in three figures, so 30 degrees as a bearing is 0, 3, 0 degrees. Jobs again. Okay, next up we got another bearing question. So here the bearing of A from B is 235 degrees. We want to work out the bearing of B from A. So much the same situation as the second part we did on the last page. We want this angle here. To get that, we need to work out this angle here. Again, these two angles are co-interior. So this angle here is 360 minus 235, which is 125 degrees. Then we know our angles are co-interior, so to work out the bearing of B from A, we're going to do 180 minus 125, which will give us 55 degrees. And again, remember, bearings are always in three figures, so it's 0, 5, 5 degrees as a bearing. Jobs again. Okay, next up we have angles inside of a parallelogram. So here we've got a parallelogram, it's split into three triangles. We've got two angles that we need to find, X and Y. So with a question like this, I know many people don't like them. The first thing we want to do is ask ourselves, can we fill in any blanks? Well, yes we can. We've got a triangle here in the middle, in which we know two of the three angles. So we've got an angle of 100 and an angle of 35. So if we add these two together, we get 135. So to work out this purple angle, down in the bottom right, we do 180 minus 135, which gives us 45 degrees. So this angle is 45 degrees. Now at the moment, there aren't really any other blanks that we can fill in, but remember, opposite angles in parallelograms are equal to each other. So we've got this top right angle of 130 degrees. That means this whole angle down here is also 130 degrees. So we now know that one of those angles is 45 degrees. So we can work out angle X, which is just this part. We know that X then is 130 minus 45, which gives us 85 degrees. Okay, and then to work out angle Y, well, remember that angles in a quadrilateral add up to 360 degrees. We know the top left angle and the bottom right angle together are 130 and 130, which is 260. So we know that the top right angle and the bottom left angle together are whatever is left when we take 260 away from 360. So 360 take 260 is 100. Now we know that this bottom left angle together is half of that. So 100 divided by 2 is 50. So we know that this angle here, the Y at 35, is 50. So take away the 35, Y is 15 degrees. Jobs are good. Okay, next up we've got some angles between parallel lines. Now they're all algebraic. Now what we want to do here is work out the size of angle W and the size of angle Y. So how in the world are we going to do that? Well, these two lines are parallel. It says that in the question. So that means that this angle 2x plus 10 and this angle 3x minus 20 are corresponding angles. Now corresponding angles are equal to each other. How in maths, if two things are equal, how do we show that? We whack an equal sign in between them. So we can say that 2x plus 10 is equal to 3x minus 20. So all of a sudden we've got ourselves an equation in terms of x that we now need to solve. So if we take away the 2x, first of all, we're left with 10 equals x minus 20, and then if we add 20, we get 30 is equal to x, or x is equal to 30. So now we can work out the size of these angles. So 2 times 30 add 10 is 70 degrees. Now we know, because these angles are corresponding, that 3x minus 20 is also 70 degrees. Let's check it though. 3 times 30 is 90, minus 20 does indeed give us 70 degrees. Now we can work out the size of angle W. So angle W is vertically opposite to 2x plus 10. Vertically opposite angles are equal, so W is also 70 degrees. Then we need to work out the size of angle Y. Well, Y and 3x minus 20 are angles on a straight line. Angles on a straight line add up to 180. So Y plus 70 is 180 degrees. Take away the 70, Y is 110 degrees. Job's a good one. Okay, next up we have more angles between parallel lines for fun. So here we've got ABC is a triangle with AB is equal to AC. So that's important. That tells us this is an isosceles triangle. So that's always useful if it's the case. We know that BA is parallel to CD. We've got this angle down here of 15 degrees and a right angle. We want to prove that angle X is 30 degrees. So how are we going to do that? Well, again, let's just fill in any blanks that we can. So, because this angle here is a right angle, that means this angle here is a right angle. So, all of a sudden, we've now got a triangle in this bottom, the bottom triangle, where we know two angles, 15 degrees and 90 degrees. So 15 add 90 is 105. So this angle down here is 180 minus 105, which is 75 degrees. So that angle is 75 degrees. Now remember, this angle is the bottom angle, or one of the bottom angles, of an isosceles triangle. So, because this angle is 75 degrees, we also know actually this whole angle here is 75 degrees too. And that's because ABC is an isosceles triangle. How is that useful? Well, that now means that we can work out the angle at the top of the triangle. So the angle here up at A. So 2 times 75 is 150. So A is 180 minus 150, which is 30 degrees. Now that, funnily enough, is what we're trying to prove that angle X is. So, can we spot an angle relationship between this angle up here at point A and this angle down here at X? Well, it's not very easy to spot, but we've got alternate angles going on. These two angles are the acute angle inside of a Z. So they are alternate angles. Alternate angles are equal. So angle A equals angle X. Therefore, X is 30 degrees. Sorry if I've just baffled you there with that little 3-dot triangle. That's maths speak for therefore. So A equals X, therefore X equals 30 degrees as we wanted to. Okay, and then the final question goes, so I've saved the best till last, angles inside of polygons. So here we've got A, B, B, C and C, D are sides of a regular polygon P. Regular means the sides are the same length and the angles are the same size. Now we've got these sides are made up between two squares and one side of a 12-sided polygon. Now, so that I don't have to keep saying 12-sided polygon, I'm going to call our 12-sided polygon Bob. So, how in the world are we going to do this? Well, first of all, I'm going to remind you about the relationship between interior angles and exterior angles. So, interior angles and exterior angles always add up to 180 degrees. Now, in our hexagon, inside of Bob, well, we know that Bob has 12 sides. So Bob has 12 exterior angles. Now the total exterior angles, doesn't matter how many sides your shape has, the total of your exterior angles is always 360 degrees. So two really important little facts there. Interior angles and exterior angles always sum to 360, and the sum of all of your exterior angles is always 360, and you always have the same number of exterior angles as you have sides of your polygon. So, using this information, we can first of all work out the size of the exterior angle of Bob. So Bob has 12 sides, so to work out his exterior angle, we're going to do 360 divided by 12, which gives us 30 degrees. So Bob, his exterior angle is 30 degrees. Bob's interior angle then is going to be 180 minus 30 degrees, which is 150 degrees. So, if we go back to the drawing now, see what we can do with that. Well, we now know this angle here is 150 degrees. Now we've got a square here, so we know that is a right angle which is 90 degrees. So we've now got 3 angles around a point. We know 2 of them. So if we add those together, 150, add 90, that's going to give us 240. So what we can do now is work out this angle here, the interior angle of polygon P. Angles around a point sum to 360, so we're going to do 360 minus 240, which is 120 degrees. So we know this angle here then, the interior angle of polygon P is 120 degrees. So what can we do now? Well, remember that interior angles and exterior angles always add up to 180 degrees. So we can work out the exterior angle of polygon P by doing 180 minus 120, which would give us an exterior angle of 60 degrees. Now remember, we are trying to prove that polygon P is a hexagon. Hexagons have 6 sides, so that means if it's a hexagon, there are 6 external angles. So what we need to check now is, does 6 times 60 equal 360? The answer is yes. Therefore, P is a hexagon. Smiley face. Okay guys, hopefully you found this useful. I thought it was a nice assortment of questions. If you want more like this before Tuesday, let me know. Or if Tuesday has come and gone and you're watching this video and you think, yeah, I want more questions like this, drop me a comment down below in the comments section. Don't forget to get subscribed. Good luck for your exams, guys. Take care. Take it easy.